Hi there. Hope you have a fantastic day today. This lesson, I will teach you how to solve problem involving exponential functions. Of course, there is a PDF file versions on the description below for you to download so you can work with me. Otherwise, let's go straight into it. First one, the temperature of a cup of coffee is cooling down over time, where T is the temperature in degrees Celsius and T is the time in minutes. So the functions for the temperature of a coffee is given by this. And part A, find the initial temperature of the coffee. Initial means when times is start at 0, okay? Initially means when T is start at 0. So when T equals 0, we just substitute T equals 0 into the functions. So the temperature, capital T, which is equal to 25 plus 50 e to the negative 0.432 times 0. But we know that anything times 0 is 0. So any numbers that power of 0 is 1, right? So therefore it should be 25 plus 50. Otherwise, I can just put that on a calculator. So just go 25 plus 50e. So I press shift and then the LN button. And then go negative 0.432 and bracket 0. And I should get 75. So there you go. So the answer is 75 degrees Celsius. So there you go. That is the initial temperature of the cup of coffee. Part B, the rate in which the coffee cools after 2 minutes. So the rate means the gradient. So the gradient means we differentiate, okay? dt and then d small t. So the questions is asking for d capital T and dt at t is equal to 2. That's what the question asks. So let me just write down the function first. So t is equal to 25 So we differentiate that dt. So we know that y is equal to e to the fx. So differentiate that. So is equal to f dash x e to the fx. Okay, keep that in mind. So we have to differentiate the power. So we differentiate this. So negative 0.432t, we differentiate that, should give me negative 0.432. Okay, so let me just write this down. So differentiate 25 is equal to 0. So that will give me 50 times by negative 0.432 and e of negative 0.432t. So there you go. So now let me just simplify this first. So just go 50 times 0.432. So the answer should be negative 21.6. So the answer is negative 21.6 e to negative 0.432t. So that is the rate. But we want to find the rate at t is equal to 2 minutes. So we just substitute t is equal to 2 into the differentiation functions. So when t is equal to 2, the rate is negative 21.6 e to the negative 0.432, we times by 2 because t is equal to 2. So now I just put that on a calculator. So I just go negative 21.6 and shift e power of negative 0.432 with times 2. So there you go. Negative 9.10 will do. Okay, so that is equal to negative 9.10 and then degrees Celsius per minute. So there you go. That is the rate at t is equal to 2. Part C. So we need to find the time it takes to cool down to 40 degrees Celsius. So we first of all, let me just write down the functions. T is equal to 25 plus 50 e power of negative 0.432 t. So now we know that the capital T is equal to 40 degrees Celsius. So 40 is equal to 25. We add 50 e to the negative 0.432 t. So now what I do, I minus 25 on both sides. So otherwise, I can just move this on that side, become minus. So 25, okay? Move on that side, become negative 25. So 40 minus 20 is 20. 20 minus 5 is 15. So 15 will give me 50 e to the negative 0.432 t. Then what I do, I divide by 50 on both sides, and I divide this by 50. So that cancel out. So I can simplify this by both divided by 5. So that give me 3, that give me 10 is equal to e to the negative 0.432 t. So what I do now is I take log on both sides. Doesn't matter what base you take, okay? But since it's e to the power of negative 0.432 t, so I take log base e, okay? So it's canceled each other out. That's why I use logs by e. But if you logs by 10, still correct. So nothing wrong with that, okay? But then we just easier, that's all. So I use log base e, that is ln 0.3, because it's 10 over 3 is 0.3 equal ln e to the negative 0.432 t. So there you go. And don't forget, and we know that ln of e to the negative 0.432 t, ln is log base e, if you like. So I just write this here so you can see log by e, e of negative 0.432 t. Now, since it is same space, so therefore they cancel each other out. So that is the same as negative 0.432 t. That's why I take log base e, okay? So now that will give me ln of 0.3 is equal to negative 0.432 t. So now what I do, I just divide it by both sides by this number here, which is negative 0.432 divided by this by negative 0.432. So this cancel out. So therefore, t is equal to, now just put that on a calculator. So I go ln 0.3 divided by negative 0.432. So there you go. So it's 2.79 minutes, okay? Round up to 2 decimal places we do. So 2.79 minutes. So there you go. Part D. After leaving the cup of coffee on the table for a period of time without drinking, the temperature of the cup of coffee eventually reached room temperature. So what is the room temperature? So let me just write down the function first. So we know that T, the temperature of the coffee, is 25 plus 50 e to the negative 0.432 t. So this can be expressed as 25 plus 50. Now I'm going to bring this down. So that becomes positive index. So I move this down, become positive, okay? So over e to the 0.432 t. So when the cup of coffee live for a long time, so this means that the t is approach to infinity. So this means that 50 divided by this becomes a very big number. And small number divided by large number, it becomes 0. So this means that this approach to 0. So therefore, when t is approach to infinity, so this means that the temperature will approach to 25 because this term becomes 0. So t becomes 25. degrees Celsius. There you go. Otherwise, you can also put that in a calculator. So let's say T is a big number. So let's say 25 plus 50 E and then negative 0.432 and we times a large number. Just say just 999. Doesn't matter. So roughly. So there you go. See, you get 25. So therefore, the room temperature is 25 degrees Celsius. Please pause the video and try this one yourself. Hi there, I'm back. How do you go? So let me go through it with you, okay? Before I do that, please do not forget to give me a thumb up and subscribe if you haven't done so you can help me to grow my channel. So let's get into it. So first one. So what is the initial value of the computer? So initial means when t is start at 0, okay? So t is equal to 0. So let me just write down the function first. S is the salvage value equals 2,500 times by 0.7 t. So when t is equal to 0, so this means that S is equal to 2,500 times by 0.7 power of 0. And we know that any numbers that power of 0 will give me 1. Otherwise, you can just put that on a calculator and you should get 2,500. So that is 2,500. So therefore, the initial So there you go. $2,500 is the initial value of the computer. Part B. So what is the value of the computer after 3 years? So after 3 years, that means when t is equal to 3. So S will give me 2,500 times by 0.7 power of t, but t is 3. So that means power of 3. So that is equal to, now just put down a calculator. So 2,500 brackets 0.7 power of 3. So there you go. $857.50. So 2 decimal place. So $857.50. So there you go. So after 3 years, the value of the computer is $857.50. Part C. How long does it take the value of the computer to drop to $1,000? So 1,000 is equal to 2,500 times by 0.7 power of t. So we need to find the value of t. So what I do, I divide by 100 on both sides. Will give me this. And we divide by another 25. So that will give me 10 over 25 is equal to 0.7 t. Then what I do, I take log on both sides. So it doesn't matter whether I take by 10 or ln, doesn't really matter. So I just use ln. 10 over 25 is equal to ln 0.7 t. Now don't forget log of CA power m, doesn't matter whatever base it is. The rule is we can bring the m in front. So that's what that meant. Right? So therefore this t here we can bring in the front. So ln of 10 over 25 is equal to t ln of 0.7. Now I just divide it by ln 0.7 and I divide this by ln 0.7. So this cancel out. So that will give me t is equal to, so just put that on a calculator. So just go ln of 10 over 25, close bracket, divided by ln of 0.7. So there you go. So 2.57. Okay, so just round up to 2 decimal places will do. So 2.57 years, because t times in years. So you got therefore 2.57 years. So there you go. I hope you got it correct, and thank you so much for watching. Bye.